Have you ever wondered what existed right after the universe sprang into existence from a point of singularity? Imagine a vast, hot and dense state, a singularity where all the matter of the cosmos was compressed to an infinitesimally small point. This moment, known as the Big Bang, marks the explosive dawn of the universe. Contrary to common belief, the Big Bang was not a typical explosion scattering debris into empty space. Rather, it was the very fabric of space itself that expanded. From this rapid expansion, the universe as we understand it began to take shape, setting a profound stage for everything that followed. In these initial moments, the universe was nothing like the star-spangled expanse we gaze upon today. It was a formless soup of energy, a chaotic ballet of particles, each playing their part in cosmic evolution. This primordial phase set the cornerstone for all celestial phenomena and structures that we are familiar with. Let's dive into the first moments of our universe, a journey through time and space. Imagine a universe less than a second old, unimaginably hot and dense. This is the scene immediately following the Big Bang, a moment of creation that marked the beginning of everything we know in the cosmos. In these first fleeting moments, the universe was a chaotic soup of energy, where temperatures reached astounding levels, billions upon billions of degrees. Such extreme conditions created a perfect setting for the birth of the fundamental forces that govern the universe: gravity, electromagnetism, and the strong and weak nuclear forces. As the universe rapidly expanded, it began to cool. This cooling phase was crucial as it allowed the fundamental forces to separate from each other. Gravity emerged first, followed by the split of the electromagnetic force from the strong and weak nuclear forces. This separation set the stage for all the complex interactions that would follow. During this cooling, the first subatomic particles began to form. Quarks and leptons, the building blocks of matter, came into existence. Quarks soon grouped together to form protons and neutrons, while leptons include familiar particles like electrons. This era, though it lasted only a fraction of a second, was critical. The behaviors and relationships established among these particles and forces laid down the rules of the cosmic game, rules that still govern the workings of the universe today. As the universe expanded, it began to cool, setting the stage for the next monumental transformations. Within minutes of its birth, the universe took its first steps towards creating the building blocks of matter. As the universe rapidly expanded from the heat of the Big Bang, it began to cool, allowing for the formation of the universe's very first particles. Initially, quarks, some of the smallest known particles, clung together, forming protons and neutrons. This was a crucial stage, as these particles are the core components of an atom's nucleus. Imagine the universe as a colossal cosmic kitchen, where temperatures gradually dropped from unimaginably hot to just a few billion degrees. In this cooler environment, protons and neutrons began to interact. Through a process known as nucleosynthesis, the first nuclei of hydrogen, the simplest and most abundant element in the universe, came into being. This wasn't just any event, it was the dawn of matter as we know it. Shortly thereafter, helium nuclei formed. These events were not merely random occurrences, but were guided by the forces of nature that govern our universe. The significance of hydrogen and helium cannot be overstated. They are not only the most abundant elements in the universe, but also the fundamental ingredients for the stars and eventually for everything else that exists. As more nuclei formed, the universe gradually transitioned from a state of extreme heat and density to one that was cooler and more structured. Electrons, once energetically whizzing around, began to combine with nuclei, creating neutral atoms. With basic atoms in place, the universe was no longer a soup of particles, but a more structured space. Following its luminous start, the universe plunged into darkness. Welcome to the cosmic dark ages, an era spanning roughly 400 million years after the Big Bang. During this time, the universe was not the sparkling array of galaxies and stars we know today, but rather a vast expanse of darkness. In this epoch, the universe was predominantly filled with neutral hydrogen and helium gas. These gases were remnants from the Big Bang, thinly dispersed in space. They played a crucial role by absorbing the residual light, preventing any luminous objects from being visible. It was as if the cosmos had drawn a thick curtain across its stage, hiding its potential from view. Why is this period so crucial, you might wonder? Well, the cosmic dark ages were essential for the later formation of cosmic structures. Although it was a time of apparent inactivity and stillness, beneath this veil of darkness, gravity was silently at work. It began to pull together these neutral gases, slowly but inexorably, leading to the condensation of matter. These gatherings of gas would eventually reach a critical density, collapsing under their own gravitational pull to form the first stars and galaxies. This marked the end of the cosmic dark ages and ushered in a new era of light and formation. Thus, the cosmic dark ages, while seemingly uneventful, were far from insignificant. This dark era set the stage for the first stars to light up the universe. From darkness to light, the universe gradually awakened with the birth of the first stars. As the cosmic dark ages came to a close, a monumental shift occurred in the cosmos. This period, often overshadowed by its own emptiness and lack of light, set the stage for one of the most significant events in cosmic history, the Ionization Era. This era marked the universe's thrilling transition from a dark, neutral environment to one illuminated by the first sources of light. The seeds of stars were sown from minute fluctuations in the density of matter that pervaded the early universe. These tiny ripples grew under the influence of gravity, becoming denser and hotter. As regions of gas and dust pulled together, they reached a critical mass, and the gravitational collapse ignited nuclear fusion at their cores. Thus, the first stars were born, casting their nascent light across the cosmic void. But the spectacle didn't end with individual stars. These luminous bodies did not shine alone. They began to congregate, drawn together by their mutual gravitational attraction. Over time, these gatherings of stars formed the very first galaxies, intricate dances of light and gravity, each a small piece of a vastly expanding cosmic puzzle. These first stars and galaxies did more than merely light up the heavens. They injected energy into the surrounding medium, further leading to the ionization of hydrogen and the gradual clearing of the cosmic fog. This process allowed light to travel over greater distances, setting the foundation for the universe as we observe it today. These first stars and galaxies brought light, energy, and a new era of cosmic evolution. Fast forward billions of years, and the universe has evolved into the complex structure we observe today. What was once a uniform cloud of gas has transformed into a vast web of galaxy clusters and superclusters, each a metropolis of galaxies bound together by gravity. These structures, the largest known in the universe, span millions of light years and contain countless stars, black holes, and other celestial bodies. At the heart of this cosmic architecture is dark matter, a mysterious substance that doesn't emit, absorb, or reflect light, yet it constitutes about 85% of the total mass of the universe. Dark matter acts as an invisible scaffold for galaxy clusters and superclusters, pulling regular matter into its gravitational embrace. Alongside dark matter, dark energy plays a crucial role in the universe's saga. Making up about 70% of the universe, dark energy is an enigmatic force driving the accelerated expansion of the universe. This expansion, first discovered at the end of the 20th century, suggests that the universe is not only getting larger, but doing so at an ever-increasing rate. As astronomers peer deeper into the cosmos, they find that the universe is not winding down to a quiet end, but is dynamically expanding, hinting at mysteries that remain unsolved. What will be the ultimate fate of the universe? This question remains one of the most profound and intriguing in modern cosmology. From a hot, dense state to a vast cosmos filled with galaxies, stars, and planets, our universe has come a long way. We've traveled through billions of years of cosmic history together in just a few minutes. From the initial burst that set the universe into motion to the creation of fundamental particles swirling in the infant universe, we witnessed the formation of nuclei and the first neutral atoms, setting the stage for everything that was to follow. Then, as the universe expanded, darkness was pierced by the first stars and galaxies, lighting up the cosmos in a spectacle of creation and transformation. These celestial bodies clustered together, forming the vast cosmic structures that cradle the diversity of the universe we explore today. Even now, the universe continues to expand and evolve, inviting us to delve deeper and understand more. Each discovery peels back a layer of the cosmic mystery, revealing the intricate tapestry of space and time. If you found this journey through the cosmos as fascinating as I did, don't forget to like, share, and subscribe for more thought-provoking content. Until next time, keep looking up and wondering about the universe.